Hey guys, welcome back to the shop. I've got a pretty fun project here today I've been thinking about for a little bit, and that is creating a Sanmai style blade. And I want to use a Damascus cladding that we're going to build from 1045 steel and pure nickel. So I'm starting with some drops from my 1045 stock that I typically use for hammers, and we're going to go ahead and forge those out into long bar stock that we can then make a billet from. Of course, the press is pretty handy for this in the beginning stages. Your forging press likes large stock that holds a lot of heat. Really get some work done on there and squish that down. After a bit, I'm able to move on to my power hammer. This is a 50-pound Little Giant, and I just put these new dies on there with the more aggressive side and the flattening side, or flat side. So it's fun to be able to use those and get to know them a little bit. So there's the two pieces of bar stock that we ended up with from those two round-ish chunks of 1045. Next, I'm going to cut them up into 4-inch sections, and we can go ahead and clean off the scale so that we get a good forge weld between each layer. Next, I have a roll of pure nickel, and it's about 0.2 millimeters. I'm not sure what that converts to in inches, but it's thin, I know that, and it's going to give us should give us a nice contrast, because the nickel is very bright compared to even the medium or lower carbon steel like this 1045. Of course, the nickel content in your 15 and 20 steel is what gives it the contrast between the other carbon steel that you would use in a typical pattern welded billet. So there we've got our billet all assembled, and I've arc welded the ends, or the sides at the ends, just to hold everything together. The WD-40 that I'm spraying on there aids in the forge welding process, and we can go ahead and set the weld in the forging press. This went together quite nicely, and was able to forge it out into another long bar. And at this point we have a layer count, but I'm going to recut it and restack it and then add some additional layers of nickel in there, and that should put us up to around 170 layers between the 1045 and the nickel pieces. So on this one, I decided to compress the stack just a little bit as it was heating up to eliminate some gaps, and then of course go ahead and set the forge weld. The flux that you see there, you see me putting on the white powder, that is borax, and that's necessary in an open atmosphere forge welding situation. So we've got our bar forged out there, and it's now about 170 layers, and we can go ahead and assemble our final billet. This is the billet that will be forged into the actual blade. So you can see that centerpiece I just put down, that is 52100 high carbon steel. So we've got 52100 in the middle, nickel on each side of that, and then our nickel and 1045 stacked cladding. Cool shot of drawing that out shortly after setting the weld. That flux is flying off of that billet there. You could set the weld in the power hammer, but when the press is available, it just does such a great job. So now I need to draw this out, thin it down, and then we can start forging it into a blade shape. And the first recognizable thing or the first recognizable characteristic of a blade that I'm going to do is the actual point or tip of the knife. Cut it off at an angle there and forge that around for the edge. There was some minor delamination on both ends of the billet here, and so cutting off a little bit is sometimes necessary. It's not uncommon to have that happen just at the ends of your billet. So I've got the handle or the tang forged in and the point of the blade. Now I need to start working on the bevel, and I did a counter bend on there so that as I forge the bevel and spread the steel on one side of the blade, that's going to necessarily straighten that blade out and pull that back around. There will be minimal straightening to do once the entire blade is forged. Using the drawing side of the dies there a little bit to continue that bevel forging and then finish it out by hand. The drawing dies also came in handy when I needed to widen the handle out towards the end a little bit and get that thinned down some more. So the forging is complete. I've straightened the blade, and we can go ahead and begin the heat treatment, which involves multiple different cycles doing different things on the blade. And this first one is a normalizing cycle, and then we'll run a process anneal and a couple of thermocycles after that. At this point, the blade is process annealed, and I'm going to go ahead and clean up the profile a little bit, and you can see that I've got holes drilled in the tang as well. That's the time to do that. Next, you're seeing the quench, which is where the steel is hardened and the blade actually begins to be useful. Necessary after hardening, of course, is the tempering cycle to remove some of the hardness and impart toughness to the blade. And at that point, we can begin the finishing stages on this project. Of course, that includes more grinding, and I did not rough grind this blade because I did forge the bevels in quite thin. We'll use the old standby, the KMG Classic grinder, and grind these bevels in. I like to start with a 40 grit ceramic belt and work my way up from there. Once I've got the blade hand sanded down to a higher grit, we can go ahead and do the etching process, which reveals the pattern that we've put into the steel up to this point. The etching process involves multiple trips in and out of the etch and cleaning the blade with high grit sandpaper. We'll go ahead and use some cocobolo wood for the handle skills on this one. I really like cocobolo, and it comes out pretty nice. Even though cocobolo has a high natural oil content, I'll go ahead and put just a little bit of Danish oil on there. Puts a little darker color to the wood and just helps protect it a little bit more. I'm going to show you some pictures of the knife in just a second here, but after that I'm going to do something I don't normally do, and that is provide analysis of the project. What went well, what I could have done better, things like that. This is all in the interest of providing high quality bladesmithing content, so if that piques your interest, stick around for that after the photos, and we'll get into some of the finer details of this project. As always, appreciate you guys watching, and don't forget, if you've enjoyed this content, you can support the channel simply by leaving a comment, hitting the like button, enable those notifications, and subscribe. All that stuff is free, helps the channel out, and I surely appreciate it. So as always, thanks for watching, and we will see you on the next video. right, here we go. After action review on this knife. So I'm going to start with the good, and then we'll talk about a few things that could have been better here and what I was attempting to accomplish. So first of all, overall the knife turned out great. It's designed well. This is not my design, of course. It's my take on a classic gyuto design, but not something that I came up with from scratch, obviously. So it's kind of hard to go wrong with classic designs. But it's got an upsweep to the handle, and that combined with a realistic blade width that gives you the clearance on your cutting board that you want without running your knuckles into the board. It's got a rounded spine and drop edge here for user comfort. The handle feels great, very comfortable. Got a nice positive grip too with these facets here. Nice cocobolo wood. Nice distal taper here. So for a larger or medium to larger chef's or kitchen blade, it is not heavy. It's very it feels great in the hand. It's balanced. It's pretty well balanced. I guess it could be a little bit heavier in the back end here, but really close to where you want it for a nice pinch grip. So a lot of great things about it. The grind, you really want to pay attention to that. It's nice and thin all the way down here, so it's a high, full flat grind. And when I put the edge on here, it'll be a great blade. And on that note, we can look at the thickness here, what it's going to be behind the edge once we put that in. I can get the crud off my calipers here. And this is, it's about 10 thousandths. So that's pretty good. So 910 thousandths. So anyway, a lot of great things about it. But I wanted to point out specifically the, and of course, it's got a cool pattern. It's got some cool aesthetic elements to it as well. But I wanted to point out in specific, the Sanmai construction or execution here. So you'll see how we've got some big spaces here with the core high carbon 50-100 steel, and then over here likewise. And I just wanted to point out that was not what I was going for. What I was going for was a width between the cladding and the core steel of about, that was revealed of about right here. This from here to here, from the heel to midpoint on the blade, that looks really good. And from the heel to right about here, that looks good too. And then we get into these spots here, and we get some real high lines on the cladding. That is not what I was going for. And so, and the reason for that is because a Sanmai, traditionally, the intention behind it was to provide support for a harder and therefore somewhat more fragile core steel, and also to minimize the amount of high quality steel that was necessary to make an entire blade. As I understand it, those are the two main motivations for the Sanmai construction traditionally. And so, following that that design is what my intention was. Now, in this case, I'm really not concerned so much with the I'm not concerned with the integrity. I'm really not concerned so much with supporting the 50-100 steel. It's a very tough, capable steel on its own. The amount of material we have here is adequate, and for this given task, I'm not concerned with this blade. I'm confident it will perform just fine. But in the interest of executing a design as well as we can, I was going for something that would have followed lines like this all the way down. Okay, so that's the first thing. The second thing is the pattern really did not turn out quite like I wanted to. And what I was really going for was what you can kind of see in this area right here. This turned out okay, where you have some visible lines on your pattern between the nickel and that 1045 steel. And then right here is pretty good too. But then you get into a lot of this here that's just kind of a homogeneous sort of bright color. and you can't really discern any layers in there in a lot of this stuff, except for the the intermediate layers that we put in. And so that really wasn't quite what I was going for. All right, so there's the two issues that I have with this project. Now, how do we fix those? How did those happen? All right, so let's go back to the Sanmai construction and talk about what happened and how we ended up with this. So you'll notice that this is a direct reverse of this side. See how it comes down here, but it goes up here. All right, so basically what happened is when I forged this out, and this is after I got off the power hammer and finished forging the bevels in by hand. I did not evenly forge that by hand enough out here to provide an even, to provide that center steel a good even distance between each side. So I kind of pushed it over is what I'm trying to say. And you can verify that by noting that I pushed it over to this side in this particular spot. That's why when you grind it, it took off more of the cladding here and less of the cladding here. So it's a pretty telltale sign. And then similar on this and this here. And so if you have, unequal hammer blows like that, and then you come back and then you straighten the whole thing without addressing those thickness and uniformity issues, then you're going to straighten the blade and it'll be straight, but your components in between are not necessarily in line. And so hopefully that makes sense. So then when you come to grind it and follow the straightness of the blade, you're revealing where some of that material had been pushed to one side or the other. So that could have been avoided with that. Secondly, I did not, and I was slightly concerned about this. I should have been more concerned about it, but I did not control the ratio of my cladding versus core steel quite like I should have. I had the cladding pieces a little bit too thin, or you could say the core steel was a little bit too thick. So the core steel was from 1/4 inch stock, but it's oversized, so it's more than 1/4 inch. And then the core steel, I was meaning to forge to 1/4 inch, but it got a little bit smaller. So what then happens is when you go to grind it, you end up taking more of your cladding off than you want on that angle and revealing more of your core steel. Now, if this core steel had been thinner in the first place, there would be less of it in there, and then it would reveal further down towards the edge. Okay, so there's a couple of reasons why we ended up with this, and that's something to learn from and to improve on in the future. Now, when it comes to the pattern, I think the main thing that happened was just a lot of hammering, and I should not have folded my cladding steel as many times and left it a lower count pattern, and I think we would have been okay. But when you get up into the higher or the finer patterns with the higher layer counts, it's often susceptible to a lot of hammering, and you can really just kind of meld those layers together. And then when you go to etch it, it's somewhat less than what you expected. And so that's kind of what happened there, to my knowledge. And I think the fact that it was nickel and also that lower carbon steel, that 1045, it does not resist the forging like the high carbon does, and you really notice that when you're working with it. It feels like butter, but it's going to deform more and really kind of squish that together more than you would, say, on a 1095 and 15 and 20 layered steel billet. So lots of little things that you don't think about necessarily, and some of these I did think about but did not quite execute like I was hoping. So it's a great opportunity to learn from and do better on the next time. But overall, this is going to be a very nice, very functional, great knife for somebody to use and to enjoy for years and years and years to come. I'm just going to sell it for a little bit less than I normally would because of the technical things to it that maybe a lot of people wouldn't even care about. But as a bladesmith seeking a high level of excellence, I'm aware of these things and will continue to move forward and continue to make awesome blades. So thanks, guys. Appreciate it. We'll see you on the next one.